Can you hear me now? Yeah. Now you can hear me. There's audio now. Awesome. Okay. Victory. Again, I was saying this earlier. Apologize for the delay. There were many changes both in how YouTube wanted me to do this and my computer's new operating system. But now we're here and we're reviewing. So, as I think I've mentioned before, I'm going to go over the core standards quizzes from the quarter so far. If at any point you have any questions or comments or thoughts, anything like that, please let me know in the chat and I'll respond. If you're watching this later, you should be able to see the chat and respond, but you won't be able to ask any new questions. Any questions before I get started, or any things you particularly want me to cover, or any questions you want me to make sure to focus on? Cool. Let's do it. So this is our very first quiz. Quiz number 1 on quadratic standards, quadratic functions, and we had a linear function, a quadratic function, an exponential function. So on number 1 of our very first quiz of the whole quarter, we should have looked at how the function changes as we increase. So this one goes plus 5, plus 7, then plus 9. We should have seen down here, I'm going to write that an f of x as x increases by 1, f of x has a common second difference of 2, because as the differences are not the same, but here the difference in the differences is always 2. So this must be a quadratic function. So I know that f of x is going to be an x squared. So I'm thinking about, I'm going to add a little column here and say I know it's x squared. Let's see, 2 squared would be 4. 3 squared would be 9. 4 squared would be 16. And 5 squared is 25. And then my next question becomes, how would I get f of x from x squared? Well, here, plus 1, plus 1, plus 1, plus 1. So my pattern is x squared plus 1. Okay, then in g of x, I'm looking at the differences and I see plus 3, plus 3, plus 3. Great! So I can come down here and say as x increases by 1, g of x has a common difference of 3. Okay, so it's got to be a linear function with a slope of 3x. And then I'm going to make a little column here and say, what's 3x? Well, 3 times x here will be 9. 3x here would be 12. 3x here would be 15. And 3 times 6 would be 18. And then my question becomes, how would I get to 16? Well, that would be plus 7, and plus 7, and plus 7, and plus 7. So I'm thinking my function is 3x plus 7. And h of x. So I'm looking at 36, 108, 324, 972. I don't think that there are any common differences. They seem to go up by quite a bit. I'm saying that 36 to 108 I could times by 3, and times by 3 again, and times by 3. So h of x is an exponential function. So as x increases by 1, h of x has a common ratio of 3. So I know that means it must be some form of a function that has 3 to the x. So I'm going to go in here and say, let's make a 3 to the x column. 3 to the x. Well, 3 squared would be 9. 3 to the third would be 27. 3 to the fourth would be 81. And 3 to the fifth, I think, is 343. No, that can't be right. 3 to the fifth is 81, and 81 is 162, 243. That's what it is. There we go. And then I'm asking myself the question, how would I get to 36 and 108 and 324 and 972? And I'm seeing I could use times 4 to get 36, and times 4 here to get 108, and times 4 here, and times 4 there. So I've got 4 times 3 to the x, which generally gets written that way. Cool. An exponential function, a linear function, and a quadratic function. Quadratic, linear, and exponential. And these two were the ones you studied in Math 1. So they should have been Math 1 review. So Juan's asking, is this core or additional? This question did go in a core standards grade, but really the core standard that you're thinking about for your upcoming test is doing that. No, that for the test. You want to be able to get quadratic functions. That's the core idea. Oh, and a skitlet had your back, Juan. Thank you, a skitlet. This here, this review, that's important stuff. It'll come up all year long. but that's math 1, not math 2. Cool. That was it for number 1 on quiz 1. Any questions on number 1 on quiz 1? Seeing no questions, I'll move on to number 2, where we are graphing. Okay, and we were asked to make a table and then plot the points on the table. And I'm starting with 6 times 1/2 to the x, and I'm going to do -3, -2, -1, 0, 1, 2, 3. And 6 times 1/2 to the -3rd power. Well, 1/2 to the -3rd power is, let's see, I'm going to make some extra space over here to the right. And so I'm starting with x, -3, -2, -1, 0, 1, 2, 3, and f of x. So I've got 6 times 1/2 to the -3rd. Which is the same as 6 times 2 to the +3rd, which is 2 to the +3rd is 8, so 6 times 8, so 48. Well, doesn't really fit on my graph very well. Oh well. 6 times 1/2 to the -2 equals 6 times 2 to the +2 equals 6 times 4 equals 24. Also not a great fit on my graph. 6 times 1/2 to the -1 equals 6 times 2 to the +1 equals 6 times 2 equals 12. Okay. Ooh, great question. How did the -3 change to a +3? Okay, so again, expanding out. So what I used here, and let's go more in depth. What happened here was I had 6 times 2 over 1 to the +3. So I applied the law of negative exponents. What a negative exponent is a positive exponent to the reciprocal. So because the 1/2 flipped over and became 2 over 1, I got to change from a -3 to a +3. Which I then wrote as 6 times 2 to the 3rd, which became 6 times 8, which became my 48. Did I answer your question, a skitlet? Excellent. Cool. So now I'm here at 6 times 1/2 to the 0, which is anything to the 0 power is 1. So 6 times 1, which is 6. Oh, and we're going to put 6. Let's see. When I plugged in -1, I got 12. So I'm going to put that in there. So here's 11 and then 12. 11, 12. And -1 made 12. And 0 made 6. Okay. And 6 times 1/2 to the 1, which equals 6 times 1/2. And that's 6 over 2, which is 3. So when I plug in 1, I get 3. So here I went left 1 and up 12, then over 0 and up 6, and then over 1 and up 3. And 6 times 1/2 to the second power is 6 times 1 squared over 2 squared, which is 6 times 1/4, which is 6 over 4, or, when reduced, 3 over 2, or 1.5. So when I plug in 2, I get 1.5 over 2 up 1.5. And last one I'm going to do 6 times 1/2 to the third power is 6 times 1 cubed over 2 cubed, which is 6 times 1/8, which is 6/8, or 3/4, or as a decimal, 0.75. So I can go over 3 and up 0.75. And you can see each of these points will get half as tall as the one before and get closer and closer and closer to the x-axis. So there's my graph. And let's fill in our table. We had 24 and 12 and 6 and 3 and 1.5 and 0.75. Okay. I'm going to take all of that and put it out of the way. But just in case you wanted a last look at it, sorry. There it is. And I'll move it. Grab it if you need it. Now moving on to part B. And I'm going to go here. 0, 1, 2, 3, 4, 5, 6. And I'm doing that because I notice here that I want to find out what's happening when the quadratic or the squared term makes 0. So I can see that this here in parenthesis will be 0 when x is 3. So I want some values that are less than 3 and some other values that are more than 3. And some room to work our table. So I've got x, and this is h of x, and 0, 1, 2, 3, 4, 5, 6. And here I've got 0 minus 3 squared minus 5, which is negative 3 squared minus 5, which is 9 minus 5, which is 4. 4. So I'm going to plot 0 left, right, and up 4. 0, 4. And then I've got 1 minus 3 squared minus 5, which is negative 2 squared minus 5, which is 4 minus 5, which is negative 1. So 1, negative 1, go over 1 and down 1. And 2 minus 3 squared minus 5. 2 minus 3 is negative 1 squared minus 5 equals 1 minus 5 equals negative 4. So 2, negative 4 over 2 down 4. And 3 minus 3 squared minus 5 is 0 squared minus 5, which is 0 minus 5, which is negative 5. Plug in 3, get negative 5. And 4 minus 3 squared minus 5 is 1 squared minus 5, or 1 minus 5, or negative 4. So 3, negative 5. So 4, negative 4. And then 5 minus 3 squared minus 5 equals 2 squared minus 5 equals 4 minus 5 equals negative 1. So plug in 5, get out negative 1. And 6 minus 3 squared minus 5 is 3 squared minus 5, which is 9 minus 5, which is 4. So I have this function there. Okay, and moving on to part C. And again, I'll need to make a little room with a box over here. So I'm going to say, let's check out -2, -1, 0, 1, 2, 3, 4. And really any x values you use here are going to be good. X, g of x, -2x plus 5, and -2, -1, 0, 1, 2, 3, 4. And I've got -2 times -2 plus 5, which is 4 plus 5, which is 9. -2, 9. Left 2, up 9. And -2 times -1 plus 5 is 2 plus 5, which is 7. So -1, 7. And -2 times 0 plus 5 is 0 plus 5, which is 5. And -2 times 1 plus 5 equals -2 plus 5, which is 3. So I had 0, 5, and 1, 3. And -2 times 2 plus 5 equals -4 plus 5, which is 1. 2, 1. And -2 times 3 plus 5 equals -6 plus 5 equals -1. And hopefully the pattern has become pretty clear for you. But just to finish out the table, I've got -8 plus 5 making -3. And I could connect those points with a nice smooth line. And there's the graph of g of x. Okay, and let's get the last one, d. And again, I'll make some workspace over here. And I'll choose some x values. Here, I'm seeing that if I plug -1 in, that would give me 0 squared. So I want some values that are less than -1 and some values that are more than -1. So 0, 1, 2, and -4. And this is j of x, and -4, -3, 1, 0, 1, 2. And I'll probably need a little more room here. So that should do it. And let's see, I've got negative negative 4 plus 1 squared plus 8, which is negative. Negative 4 plus 1 makes negative 3 squared plus 8, which is negative. Negative 3 squared is 9 plus 8. Negative 9 plus 8 is negative 1. Equals negative 1. So when I plug in negative 4, I get negative 1. And plot that point. Left 4, down 1. And negative. Negative 3 plus 1 squared plus 8 is negative. Negative 2 squared plus 8, which is negative. Then negative 2 squared is positive 4 plus 8, and negative 4 plus 8 is 4. So negative 3 made 4, and negative 3 up made 4. And negative 2 plus 1 squared plus 8 is negative. Negative 2 plus 1 is negative 1 squared plus 8. Negative 1 squared is 1 plus 8. Negative 1 plus 8 is 7. So I had negative 2, 7. Okay. Negative 1 plus 1 squared plus 8, which is negative 0 squared plus 8, which is 0 plus 8, which is 8. One, 8. And negative, oh, I don't like that. Negative 0 plus 1 squared plus 8 equals negative. 0 plus 1 is 1 squared plus 8, which is negative 1 plus 8, which we know to be 7. 0 made 7. And negative 1 plus 1 squared plus 8 equals negative 2 squared plus 8 is negative 4 plus 8 is 4. 4. 4. Negative 2 plus 1 squared plus 8. Negative 3 squared plus 8 is negative 9 plus 8, which is negative 1. 2, negative 1. And I have that curve. Let's see. If I plugged in 3, negative 8, there it is, like that. That's j of x. Any questions about any of my work? on A, B, C, or D on quiz 1. Or, in fact, any of my work at all on quiz 1. Okay. Thanks to Skitlet. Let's look at quiz 2. All right. Suppose Brett, and Andre each throw a baseball into the air. Height of Brett's baseball is given by negative 16t squared plus 79t plus 6, and a table is given. The height of Andre's baseball is graphed below. Okay. A, complete the table for Brett's baseball's height over time. So I just plug in 0, which is 0 squared is 0. 0 times negative 16 is 0. 79 times 0 is 0. 0 plus 0 plus 6 is 6. Then for some other values, I think you definitely would have wanted a calculator. So I'm going to come in here and make a table. This is T H of T equal to negative 16t squared plus 79t plus 6. And we had 0, which we got 6. 1 gave us 69. 2 gives me negative 16 times 2 squared plus 79 times 2 plus 6. Let's see. 2 squared is 4. Negative 16 times 4 is negative 64. 79 times 2 is 158. So negative 64 plus 158 is 94 plus 6 makes 100. And then 3 negative 16 times 3 squared plus 79 times 3 plus 6. Well, 3 squared is 9 times negative 16 is negative 144. Now I'm really stretching myself. 80 times 3 is 240, so 79 times 3 would be 237. So negative 144 plus 237 plus 6 is 99. Cool. Okay. Whose baseball went higher, Brett or Andre's? Support your claim with evidence. Okay, so I'm seeing here that Andre's baseball definitely never went over 80 feet. So I'm going to say Brett's baseball went higher. From the graph, it is clear that Andre's baseball never went over 80 feet, whereas Brett's went at least 100 feet high. Okay. How long were each of the baseballs in the air? Let's see. So, Brett's at 5 seconds is 1 foot high, so it's got to be a little more than 5 seconds. Brett's was in the air for, let's see, draw a line here, keep my work separate. A little more than 5 seconds, and Andres was in the air for just over, let's see, this spot here would be 4.2, and it's just past that, just over 4.2 seconds. Okay, and I don't think I had you do this part. This is extra on this copy of the quiz, but we would have drawn something like that, and it must have been 9. So something like that, and like that. Which makes it quite clear that Brett's was in the air for longer and went higher. Okay. That's number 1 from quiz 2. All right, this was a tough one for everybody. Let's see. We're supposed to sketch the graphs of f of x minus 3, f of x minus 5, and f of x plus 1 on the same coordinate plane. So f of x minus 3 should have been, I'm going to do this one in red, 1, 2, 3 spaces to the right. So I'm going to copy this parabola that's given, the parent function x squared, and then I'm going to take that and move it 1 space, 2 spaces, 3 spaces to the right. And I accidentally also took that, so let's undo that. This is f of x minus 3, which is also known as x minus 3 squared. And if we were able to, let's make some more workspace, make a table on x minus 3 squared, we could see, let's just check out 2, 3, and 4. It would be 1, 0, 1. So that's this point, and this point. all just to the right. Okay, and then I'm going to make my next one in blue. And again, I'm going to copy the parabola. And f of x minus 5 is going to move me down 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces. So that's that one in blue. And we could see here, okay, so this is my red table. This is going to be blue next. So this is f of x minus 5, which is x squared minus 5. And if we made a little table real quick for x squared minus 5, that would be negative 1 makes negative 4, and 0 makes negative 5, and 1 makes negative 4. So that could go like that, and like that, and like that. And I'll do the last one in green. And again, I'm going to copy it and move it 1 space left. So that's f of x plus 1, which is also known as x plus 1 squared. And if I were to make a little table of x plus 1 squared, I could have done negative 2, negative 1, 0, which would have made 1, 0, and 1. Cool. So here you can see that x values 1 less than the values in f of x make the same outputs. So all these x values moved left to make the green function. Here in blue, when I use the same inputs, I get outputs 5 less. So all of the y values moved down. The whole graph shifted down 5. And here, when I use x values 3 larger, I get the same outputs as in f of x. So that means the graph moved to the right 3 spaces. That's number 2. Any questions on number 2? Hopefully no. So I've got number 3 with some more graphing. Again, I'm going to make a table and say x. Let's make some more workspace. And go x. F of x. And I'm noticing that in order to make the squared term be 0, I should use 1. And I want some numbers that are less than 1 and some numbers that are more than 1. So negative 1 minus 1 squared minus 4 is negative 2 squared minus 4 which is 4 minus 4, which is 0. So when I plug in -1, I get out 0. So I'm going to set up my y-axis and my x-axis, and -1, 0. And 0 is 0 minus 1 squared minus 4, which is -1 squared minus 4, which is 1 minus 4, which is -3. So 0, -3. And 1 minus 1 squared minus 4 makes 0 squared minus 4 makes -4. So plug in 1, get -4. And 2 is 2 minus 1 squared minus 4, which is 1 squared minus 4, which is 1 minus 4, which is -3. And 3 minus 1 squared minus 4 is 2 squared minus 4, which is 4 minus 4, which is 0. And if I did 4, that would make 3 squared. 9 minus 4 would be 5. There and there. So now I've got that beautiful parabola. There. Okay, that was A and B. -x plus 2 squared plus 9. Again, we'll want some workspace. And x f of, or g of x. Let's see. Maybe we used our understanding in our last problem and realize, well, probably at this point when you're doing this quiz, you didn't quite realize this. But soon here we should be saying, all right, that goes left 2 and up 9, and this flipped over. 2, 3, 4, 5, 6, 2, 3, 5, 6, 7, 8, 9, 10, 2, 3, 4. So I want to use some values that center around -2. So maybe -3 and -4 and -1 and 0. And -4 plus 2 squared plus 9 is -2 squared. And as usual, I have to back out, give myself a little more room. Squared plus 9, which is -4 plus 9, which is 5. -4, 5. And -3 plus 2 squared plus 9 equals -1 squared plus 9, which is -1 plus 9, which is 8. Okay. A skitlet, I think I'm only going to do the quizzes because I'm going to be done in 14 minutes. So I'm going to do this quiz. Maybe I should speed up. And then look at the very most recent quiz. -2 plus 2 squared plus 9 is going to be 0 plus 9 is 9. And 8 and 5. So I had 8, 9, 8, 5. I plugged in 1, 0, 0. So I had that graph. Of g of x. Okay. Most recent quiz. If f of x is x squared, graph -1/2 x squared, and tell me how to get from f to g. Okay, so at this point, you're on quiz 3. We, as you may have noticed watching this video, have graphed a lot of parabolas. You should kind of know how they look by now. So maybe you're saying, all right, 0 squared, 1 squared, 2 squared's 4, 3 squared, 5, 6, 7, 8, 9. Bam, that in blue is going to be the parent function x squared. And then when I reflect it and make it half as tall, I get this one. Half of 4 is 2. Let's see, 4 squared would be 16. Half of that is 8. 3, 4, 5, 6, 7, 8. And 8. Okay, so that was f of x equals x squared, and g of x equals negative 1/2 x squared. And the steps here would be 1, dilate about the x-axis by 1/2. And step 2, reflect over the x-axis. And here we go on h of x. I'm still starting with the same blue graph of x squared. And then I need the same graph 8 spaces to the left. So I'm going to make a copy in purple and move it 8 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8. There's f of x equals x squared, and h of x equals x plus 8 squared. So that means to get from one to the other, I would say translate 8 to the left. Ooh, and here's the good one. C. Okay. This one would have a blue graph of x squared. And then negative x plus 2 over 3 squared minus 5. So I'm going to flip it over. I'm going to go left 2. I'm going to go down 1, 2, 3, 4, 5 to right there. And it is stretched out by a factor of 3. So there's my graph right there. And I could say 1, translate left two. Well, actually, I should really start by saying dilate away from the y-axis by 3. Then translate left 2. Then reflect in the x-axis. Then translate down 5. So that part did that, and that part did that, and that part did that, and that part did that. Okay, I have 5 minutes left. I think I'm going to skip number 2 because I've plotted a lot of functions by plugging things in. So I'm going to jump over to number 3 with my last 5 minutes. Finding and interpreting the intercepts. So the y-intercept is at 0, it's a little above 5, I'm going to say 6. So the ball was 6 feet tall when launched. And I'm going to say 4.1, a little after 4. The x-intercept is 4.10. So the ball hit the ground after 4.1 seconds. And I'm going to squeeze that down to fit it here. So I can go on to part B. And the function is increasing from 0 to 2 seconds. So the ball was going up during that time. And the function that's this time is decreasing from 2 to, I'm going to guess, 4.1 seconds. So the ball was going down during that time. Whew. The maximum height looks like 70 feet. And the domain question was an extended standard. Well, we can answer it. The domain was from 0 to 4.1 seconds. And it is 9 o'clock. And those were the core standard quiz questions from quarter one so far. What do you guys think? Any last remaining questions? You are welcome. Good luck on your quiz tomorrow. Oh, I like Dr. Respect Women. Very nice. You are welcome. Anyway, see you all tomorrow. Hope it was helpful. Have a good night.